welcome to our very first Planetarium online presentation where we will be looking at the sky you'd be able to see up there tonight. My name is Scott Mitchell. I'm the director of the Orange Coast College Planetarium, and it is my pleasure to be able to bring you this program. Even though everybody is stuck indoors, of course, the sky is something that we can see whenever we want to. All you have to do is step out into your own backyard, practicing very careful social distancing. So we're going to go over some of the things that you'd be able to see tonight, and hopefully you can go outside and spot them for yourself. So let's fire up our program here. It's called Stellarium, and it's a free planetarium software that you can get from their website, stellarium.org. It's a very useful program, and it's totally free. You can download it or use it right there in the browser, and it'll show you the sky whenever you want to see it from any place on Earth, past, present, or future, and it even lets you see the sky from some other extraterrestrial locations as well. So we're going to start, of course, with our daytime sky. We can see the sun over here in the west. You can tell west from our little W there near the horizon. Now the sun, of course, is a star, the closest one to us here on Earth, only about 93 million miles away. Now the other stars can be much, much bigger than the sun, but they seem very tiny, as tiny little specks in the sky because they can be trillions and trillions of miles away, rendering them as just little dots, while the sun, being so close to us, is bright enough to block out the rest of the stars with its light. Now this gives us kind of a boring sky when the sun's up. You really can't see very much. So we're going to have to fast forward time a little bit here to drop the sun down below the horizon, and as it gets lower and lower, we'll see the sky start to get darker and we'll have some stars come out. So right about now we've got a nice good dark nighttime sky. It's about 8:30, a little bit past 8:30 we've got the sky set for right now, and that's when it'll get dark enough that you should hopefully be able to see some stars. Now, in order to orient yourself, you have to have some basis. Now, in Stellarium, it's really easy to just use our nice little letters here: south, east, north, and west. But I'm willing to bet probably most of you don't have big compass directions labeled on your horizon around your house. So we have to have a way to tell what direction is what. You could do that a couple of different ways. You could use an actual physical compass. You could use a compass app on your smartphone, or you could actually use the stars to help you figure out where you're facing. So what we're going to do is look for a very, very special star pattern that I'm willing to bet probably all of you have heard of before. And it's going to be up very high in the sky, almost straight overhead. You can probably see it right here in the middle of our screen now. This is the Big Dipper. The Big Dipper has 7 stars, 4 in the cup here, and then 3 in its curved handle. And it's a very, very important star pattern to be able to find because it can act as a guide to help you find a lot of other things in the sky. It helps with what astronomers call star hopping, where you use different star patterns and constellations to help you, trace lines and direct you towards other interesting things that you want to be able to find. Now the Big Dipper, we are going to use first these 2 stars right here, the front of the cup, and we're going to use them as pointer stars to trace a line down between them across the sky until we hit the next bright star right here. This one is called Polaris, and it is very famously our North Star. Now the North Star is going to be the tip of the handle of the Little Dipper, so just like the big one, we have 1, 2, 3 stars in the handle, and 1, 2, 3, 4 stars there in the cup. So we've already got 2 star patterns down. Now the reason we started with this one is because Polaris, being the North Star, is special. It is, you can see directly above our N there in the north, and it stays right there all the time. All of the other stars in the sky are going to move around Polaris in great big circles. They'll rise over here in the east and move across the sky and set over here in the west. but Polaris stays right where it is because the north pole of the Earth points just about directly at that star. So as we spin around, like the Earth does every 24 hours, it looks like the stars are moving. Of course, we know that it's actually the Earth turning. The stars aren't really moving around us, but it looks that way because we're standing on the Earth and the Earth is spinning. So if you can find Polaris using the Big Dipper is very bright and pretty easy to find most of the time. You can trace down, find Polaris, and now you have a pretty good idea of where north is. So the two patterns that we've already talked about, we have, of course, our Little Dipper, which officially is the constellation Ursa Minor, which is the Little Bear. And then we have Ursa Major, is the Big Bear. And you'll notice that we've got some extra stars on here that have been added to our Big Dipper. The Big Dipper is not an official constellation. It's what we call an asterism, just an easily recognizable pattern of stars in the sky. And if we add some extra ones on there, we can make something that looks at least vaguely like a bear there in the sky. So we got our mama bear and baby bear up here. So we can also use the Big Dipper to help us find some other things. Let's go towards the south this time. So starting at the Big Dipper, we can grab it by the handle and bring the cup straight down to hit on the back of the head the constellation Leo the Lion. I'm going to kind of rotate over here so we can see Leo a little bit better. So here's the Big Dipper, and if we bring it straight down, we're going to run into a very bright star over here. This star is called Regulus. Regulus is a very bright bluish white star, and it is going to be the heart of the constellation Leo the Lion. Leo has kind of a backwards question mark shape for a head here. So you can see his mane, he's got an ear, an eye, and a nose there. His paw sticks out in front of him there, and then his body comes back here with a tail hanging down like that. So there is our lion Leo, and like I said, if you bring the Big Dipper straight down, you can hit poor Leo right on the back of the head. So that's another constellation that the Big Dipper has helped us find. Let's use it to find a couple more. This time, let's use the handle of the Big Dipper. You'll notice that it's curved, and astronomers use this little saying to help us find this next star. We're going to follow the curve, or arc, to the star Arcturus. So we follow the arc to Arcturus, is this bright star right here. Now Arcturus is going to be the brightest star in the constellation Boötes. Now, Boötes is a little bit abstract, and it doesn't look a whole lot like what it's supposed to be. Now, you could argue that the bears and the lion really don't either, but this one is on another level of strangeness. To me, Boötes looks most like a big ice cream cone in the sky, where Arcturus is the tip of our ice cream cone. You go up to these two stars here to make our triangle for the cone, and then you've got the big circle on top here, which is our ice cream. And right next to it, you can see the smile of the guy that's going to eat the ice cream cone. So these are actually two separate constellations. The herdsman, Boötes, even though he looks more like an ice cream cone. And then the smile next to it is called Corona Borealis, the northern crown. And so, very clearly, this is obviously a herdsman, and this is a crown. You really have to use your imagination a lot to find some of these star patterns. And so we're not quite done yet with our arc to Arcturus. We can keep going, and after we arc to Arcturus, we speed to Spica. Spica is this bright blue-white star here, very, very bright star, and it is the brightest in the constellation Virgo, the Maiden. Virgo is a very large constellation. By area, it's the second largest in the entire sky. So we'll light her up here. And again, a very abstract constellation, but she's supposed to be the Maiden, a beautiful woman lying in the sky here. And Spica, that bright star down here, is kind of the wheat that she's holding. And next to it, you can see another small constellation that's eyeing that wheat in her hand. This is Corvus, the crow. And Corvus has an eye there, a beak. He's perched on this little star. There's his foot, and then his wing tip comes down to there, and then his tail sticks down like that. So this is Corvus, the crow. And so we can show him there too. And of course the art. Depending on who you are, you might draw the art in different ways. Usually I like to draw Corvus staring right at that bright shiny star Spica, because crows, love shiny things like Pop-Tart wrappers and jewelry and stuff. And so we've kind of come full circle here. Leo is right here above Virgo. So we have Virgo and Corvus. Boetes the herdsman, and Corona Borealis, the northern crown. Ursa Major, the big bear, which contains the Big Dipper, and Ursa Minor, the Little Dipper. So we've explored kind of from north all the way down almost to south. So let's take a look over at the western part of the sky that so far we haven't looked at. Now, over in the west, we have a lot of very, very, very bright things to look at. What we typically consider our winter sky. So in the winter time, in January, February, this part of the sky is much higher up in the south and on full display. As we get closer to May, we're going to start to lose these guys. They'll get lower and lower in the west until we won't be able to see them anymore. And then we have to wait for next December before they start coming up again. But lots of very bright things over here. We'll start with probably one of my favorites, and probably many people's favorite constellations, is Orion the Hunter. Orion, if we zoom in on him here, has a lot of very bright stars. Most famously, the 3 stars that make up his belt here in a nice straight line. His legs come down, one star there, and then the other one is kind of hiding behind this bush. If we get rid of the bush just for a second, there we go. We can see the bright star Rigel is a very bright white star. Now, if we go hanging from his belt here, we can see a kind of fuzzy object there. His sword hangs down from his belt, and right in the middle of it is what we call the Great Orion Nebula. Using the planetarium, we can get a very close look at the Orion Nebula, which is one of the most fantastic, what we call deep sky objects that you can see with a not even very powerful telescope. Should be able to spot this one. Nebulas are huge clouds of gas and dust, enormous things, bigger than thousands, millions of solar systems. And over time, gravity will very slowly bring this huge cloud in closer and closer and squeeze all that gas and dust into protostars, things that will eventually become stars. This gravity has to squeeze them very, very, very tight until nuclear fusion starts in the cores of these stars, where hydrogen is fused into helium, which it releases tons and tons and tons of energy, which makes the star burst to life and shine like all of the other ones that we can see around us. So over the course of the next couple million or billion years, this nebula will gradually shrink and clump up into different stars, and we'll have a whole new cluster of them over there. So that's the Orion Nebula, which you can find in the sword of Orion hanging off of his belt. Above his belt, we have 2 bright stars here called Bellatrix and Betelgeuse that make up Orion's shoulders. Betelgeuse is a very, very interesting star. It's a red giant star, a red supergiant even. It's about 900 times the size of the sun. It's absolutely enormous. But it's a little bit cooler than the sun, which gives it a reddish color as opposed to some of the other really bright white and blue blue stars that you can see. Red orange stars tend to be cooler, though they're still much, much, much hotter than planets. Being a red supergiant star, Betelgeuse is nearing the end of its life cycle. Stars age just like you and I do. They go through life cycles, and Betelgeuse, sometime in the next 10,000 years or so, is expected to undergo what we call a supernova explosion. A supernova is one of the most violent and intense phenomena that happen in our universe. They're when very, very massive stars die. They explode and release huge amounts of energy and create nebulas from all the leftover material, which will then eventually clump together to form new stars, starting the cycle over again. Now, Betelgeuse is doing something kind of interesting lately. And over the last 6 months or so, that star has been fluctuating in its brightness. Now, this isn't strange for Betelgeuse. It is a variable star, so its brightness does change over pretty typical and studied periods. But over the course of the last couple of months, Betelgeuse has dropped in brightness very significantly. It was the 6th brightest star in the sky and has dropped way down the charts, going from a normal magnitude of 0.45 to 0.81 as reported up here in Stellarium. So that means that its brightness has dropped a whole lot, which some people hope is a sign that it's going to go supernova sooner rather than later. And if it does happen, it'll really be a spectacular event, even for us here on Earth, almost 500 light years away. Because when it goes, it will become so bright that it'll outshine the full moon and be bright enough you can see it even during the middle of the day. So I, for one, hope that it happens sooner rather than later, because it would be the first naked eye visible supernova in many hundreds of years. So keep your fingers crossed for that. So those are the shoulders of Orion, kind of getting away from our constellations here, but the shoulders of Orion. His head is this little cluster of 3 stars there. He has one arm extended out in front of him close to the horizon now, holding a curved shield, and then his other arm is raised up above his head holding a club. Now these stars are fairly faint, so you're probably not going to be able to see them too easily, but we can light Orion up here just the same. Yeah, with our light pollution, you definitely won't be able to see most of these stars, but the 3 stars in the belt are very bright. Betelgeuse and Bellatrix are both very bright. Rigel down here, if you can see him before he gets too low and the horizon starts blocking him off, maybe you might be able to see Rigel there too. Orion, of course, is our hunter in the sky. Now, Orion has 2 hunting companions, his dogs, called Canis Major, the big dog, and Canis Minor, the little dog. The big dog we can find over here, and we can star hop to find the brightest one. You can probably already tell which one we're headed to. The 3 bright stars in Orion's belt, if we trace a line across them and follow it over here, we're going to hit this very bright star called Sirius. Now, Sirius is the brightest star in the entire nighttime sky. It's relatively close to us, only just over 8 light years away, which is still many billions of miles away, but much closer than most of the other stars around us. So Sirius will be the collar of our dog, and you can kind of see the shape here, the dog's head, and he's got a couple of legs, a body, and back legs, and a tail there, and he follows right at Orion's heels. Above, we're going to see another bright star that kind of makes a triangle with Betelgeuse and Sirius. This one is called Procyon. Now, Procyon is the brightest star in the constellation of Canis Minor, the little dog. And Canis Minor, I think, is my absolute favorite constellation in the entire sky. To draw our little dog, you start at Procyon and you draw a straight line over to this star right here, and then you stop, because that is all there is to our little dog, Canis Minor. So if you thought Boötes earlier was silly, this one is absolutely ridiculous. It's our little dog, Canis Minor, which follows along with the big dog, Canis Major, right behind Orion the Hunter. Now if we look above Orion, so here's Orion and Canis Minor, kind of above and between them we can see another constellation here called Gemini, the Twins. The two twin stars up here are Pollux and Castor, and those are going to be the heads of our twin brothers. So if we start with Castor, his head is the bright star Castor. You draw a neck down, he has one arm going over here and his other arm sticking out here. His body comes down like that and he has two legs there. His brother Pollux has much the same, a neck, an arm, another arm, and they hold hands in the middle of this star called Iota Gemini, which is a very dim star. But his body comes down there and two legs like that to make our two twin brothers Castor and Pollux, the Gemini twins in the sky. Now you can see this mysterious object just off Pollux's shoulder. That, of course, is the moon. The date that we have this set for is Wednesday, April 29th. It'll be in its just barely waxing crescent, almost first quarter phase there. As the moon orbits around the Earth, which it does about once a month, it goes through these phases where it seems to change shape and change where it is in the sky. This is because the moon doesn't give off any light of its own. It only shines because it's reflecting light coming from the sun. So the side of the moon that faces towards the sun is lit up nice and bright, and that light bounces off of it and returns to us here on Earth, whereas the side that faces away from the sun is dark. And you can see that when we zoom in on the moon here, you can see the lit up half and the dark half. And so in our sky, all we can see right now is this kind of first quarter or half of the side that faces us lit up. And over the course of the next couple of days and weeks, this moon is going to slowly move towards the east against the background of stars. So if you go out at, let's see, we're set for almost 9 o'clock tonight, you'll go out and see the moon there, and if you go out the next night, then it'll be somewhere over here, and the next night after that it'll be over here. And as it's going, it'll gradually increase in its effective size, getting fuller and fuller until in about a week after this, it'll be a nice big bright full moon. There's one more object over here in the western sky that we want to point out. It's very, very, very important, and if you just kind of look without trying to find anything, just look towards the west and pick the brightest thing you can see. That is going to be this one here. Now, we already said that Sirius was the brightest star in the nighttime sky, right? So what is going to be brighter than the brightest star? Well, it turns out brighter than the brightest star is the brightest planet. Because this is not a star at all. It is the planet Venus. Now, it's difficult to tell if you don't know what you're looking for, the difference between a star and a planet in the sky. Ancient people were only able to figure it out because the planets tend to move in strange patterns very, very slowly over the course of weeks. If you were to watch Venus, you'll see that it moves around relative to the other stars. As we go forward in time, it's going to get lower and lower in the sky every night, because as Venus is orbiting around the sun, it's going to appear in different places. And so actually, if we zoom in on Venus here, you can do this with, you don't even need a large telescope. We can see that Venus is going to look kind of similar to the moon. We can only see a thin little crescent of Venus here, but even that little crescent is definitely bright enough to make it outshine all of the other stars in the sky. Just like the moon, Venus doesn't shine with any light of its own. It's just reflecting light from the sun. So when the lit up side of Venus is facing away from us, we can't see any of it. So all we can see is the little part of the edge of Venus that is currently lit up. Venus is the second planet in our solar system after Mercury. It has very, very thick clouds of carbon dioxide, which trap lots and lots of heat, meaning on the surface of Venus it can get up to 900 degrees, which is enough to melt lead. And these thick clouds reflect a lot of the sun's light, and that's what contributes to it being so bright in our sky. So definitely try and go out and spot Venus tonight. It'll be over there in the west. If you just don't know anything else, look towards the west and find the brightest thing you can see. That'll be Venus. And really, it's going to outshine everything in the sky except for maybe the moon. Yeah, the only thing that might be brighter than Venus tonight is the moon. In fact, let's see, the apparent magnitude of Venus tonight, negative 4.52. Negative 10.77. So yeah, the moon's going to be much brighter than Venus is, but still, in terms of brightness, the moon is brightest, then Venus, then Sirius. So all of that over in the western part of the sky. Depending on when you're watching this tonight, the moon might be in a different phase, might be in a different part of the sky. So it could be in a different place, but I'm pretty sure everybody can very easily find the moon in the sky as long as it is up in the sky somewhere. Sometimes it's up during the day and you can't see it at all. So this is what we typically use as our evening sky with all of our fun constellations and star patterns. But the sky moves, or at least the sky looks like it's moving. The stars aren't really moving that quickly around the Earth. It's the Earth turning around, which causes the sky to look like it's moving. If we speed up the rotation of the Earth here, we can see our sky, our stars moving from east to west. If we look up in the north, there's Polaris. You can see all the stars moving around it in a circle. Now, as we get further and further, it's already 1:30 in the morning. I just want to look at some things over in the southeastern part of the sky just before the sun comes up. So we'll get up a little bit further. Yeah. So this is about 4:30 in the morning is when you're going to have the best view of this before the sun comes up and starts to block out the rest of the stars. We can see three very bright objects right here, which are three more of our planets. The brightest of them is this one, Jupiter, the largest planet in our solar system. And if we zoom in on it with our telescopic view, we should be able to see the planet itself. Depending on how powerful your telescope is, you might be able to see the bands of clouds. Oh, and we can see there's the Great Red Spot, this enormous storm that's swirling in Jupiter's atmosphere and has been for at least 400 years. And that's just when the first person to use a telescope saw it. An astronomer named Galileo pointed his telescope at Jupiter back in the early 1600s and saw the Great Red Spot there. And there's no telling how long it had been there before Galileo saw it. That storm is about somewhere between 1 and 2 times the size of the Earth. So you could fit 2 Earths across that huge storm. Next to Jupiter, we can see a couple important things around it. We've got 3 of its biggest moons. This one is Io, is the closest moon to Jupiter, and Io is the most volcanically active place in the whole solar system. Jupiter's gravity kind of squeezes and stretches it, which melts its interior, and it's constantly erupting with these volcanoes all over its surface. The other moons we can see, this one is Europa. Europa is an icy moon, which, due to the same tidal heating effect, the stretch and squish of Jupiter's gravity, has warmed up the interior of Europa to melt some of the ice, so that astronomers think that there's a huge ocean of liquid water underneath, several kilometers thick of icy crust. But there's liquid water underneath that ice, and it's possible, we don't know this for sure, but it's possible that there might even be stuff living under there. So Europa is one of the places that we really, really want to try and explore in the next coming decades, so that we can find out if there might be life there on Europa. The next moon here. Ganymede is the largest moon in the entire solar system, even bigger than the planet Mercury. It's another icy, rocky ball there floating in orbit around Jupiter. And then the last of Jupiter's moons, or Jupiter's large moons anyway, is this one called Callisto, which is another rocky, icy object. Now, Jupiter has over 70 other moons. These are just the 4 big ones that are relatively easy to spot with a telescope if you know what you're looking for. So that's Jupiter shining brightly there. Next in our line of planets across the sky here is the giant ringed planet Saturn, the second largest in our solar system. With a telescope, you should be able to see its rings surrounding it. The first astronomer, again Galileo, to look at Saturn through a telescope described it as a planet with ears, because he had no idea what these rings were. No one had ever seen rings on a planet before, so he thought they kind of looked like ears. Today we know that these rings are huge fields of rock and mostly ice that reflect the sun's light very brightly, so that it comes back and hits us here on Earth, so that we can see the rings swirling around Saturn. So even though they look like they're solid objects, it's actually many billions of pieces of ice that float around it. Saturn's largest moon is this one called Titan. It's another very large moon, bigger than Mercury, and doesn't look a whole lot like anything because it has a very thick, hazy atmosphere. It's the only other moon in the solar system that has any kind of atmosphere at all. So Titan is a very interesting place. And then our third planet in the line here, you might be able to tell already what it is just from the color alone. This is the red planet Mars, the 4th planet in the solar system, a little bit smaller than Earth, about half of the Earth's size. And if we zoom way in on it, we can see some of the surface features. We've got mountains and valleys. Can't see Olympus Mons or the Mariner Valley. Or no, I think that is Olympus Mons there. So Olympus Mons is the largest volcano in the whole solar system. Enormous. So if you picked it up and set it on the Earth, it would cover up the entire state of Utah. About the same area. And we've got Mars has 2 little tiny moons here. They're kind of potato-shaped. Probably were once asteroids in the asteroid belt that were captured by Mars gravity. They're called Deimos and Phobos. So if you want to get up really early in the morning, go out before the sun comes up, you might be able to spot our 3 planets right in a straight line across here: Jupiter, Saturn, and Mars. And so we can see our sky starting to get bright here, which means the sun is coming up and we're ready to start our next day. So that is just a quick run through of some of the things that you should be on the lookout for up in our sky tonight and over the course of the next couple of weeks. Now the sky is going to shift day by day. If you go out at 8 o'clock every night, everything will be a little bit further to the west than it was the day before. So we'll get new things rising in the east and losing some of our older winter constellations. Orion is going to be too low to see here in a couple of weeks, but this should be good for at least another 2 weeks or so to be able to find things pretty easily. So I just want to thank everybody for joining us. Hopefully you can go outside and find some of our our friendly sky objects yourself tonight, and hopefully we'll see you back at the planetarium when we open up. We've got a lot of really cool new things just waiting for the go ahead from the college so that we can open the doors up again, and we'll be very excited to see you all back in the dome. So keep up with our social media if you want updates on new programs coming down the chute when we come back. So thanks for watching, everybody. Have a great day.